Well, good morning. We're back again. Thanks for joining us. I decided to go ahead and design another house here for you. I was just going to walk you through the design. I probably will not take as much time on this design as I did on the previous design because the principles are somewhat similar, so the only difference really is the layout and design. For this design, we're looking at this one's a lot smaller, and this one's going to be an earth sheltered house. I've included pretty much all the same information. I've got the drawings, and then I've got the Revit model, and then I've got the all the backup data for all the design. So if you have any questions, leave a comment or send me a message, and here we go. This is the design for I call this one Mama's house because I designed it for my mother, but it's kind of what she wants. I don't think it's exactly what she wants, but that's okay. It can be easily modified, to meet exactly what you want. And all these designs will probably have to be slightly modified, at least for the site. So this house is a net zero energy, earth sheltered passive house. I added that this is part of the Croc House collection, since I guess I've got quite a few. This is about the ninth design I've done, so the first seven I wasn't too happy with, but these eight and nine I think have turned out pretty well. So pretty much the same general sheet. We were able to delete a few sheets out of here since the footprint is much smaller. So the footprint for this house is quite a bit smaller. It's the square footage is only around 700 square feet for the first floor, and then 100 feet for the basement. So it's quite a bit smaller. I won't waste too much time going through it, but you got the first floor here, and you can see where the not rammed earth, but the earth sheltering is. The only real difference between the other first floor and this first floor on the other design is you have the, of course, XPS insulation below grade, where it's below ground. And then I went ahead and changed it from straw bale to fiberglass for cost. And also, I'm not sure how well the straw would hold up, since there will be direct contact between the earth and this CMU wall here, the retaining wall. So there might be some moisture, some humidity issues, and I thought that fiberglass would probably hold up a little bit better against moisture than straw. Standard roof plan. There's only one story to this house. Well, there's the basement, which is just a small. I made it as small as possible while still being able to, house everything. The stairs are going to be a little tricky because it's so small. I guess the carpenter will have some fun with that. And then there's no level 2. In Revit, it's hard to delete levels, so I just left level 2 in there. But there is a storage space up above the restrooms, the bathrooms there. So, and then we got our, our layout here that shows all of the furniture and everything and casework. This is similar to the last one. It's just smaller, really. One thing, I didn't attach all the light fixtures up to the ceiling, up to the roof here. They're just kind of hanging in space. So if you see those light fixtures, just know that they're not actually going to end up hanging in space. They'll attach them somehow or another to that roof. And I didn't draw the earth down here below this. I just drew a mass. You can import into Revit like geography, I think, from like Google Earth or something. It's pretty neat. I've not really done it much, but I've seen it done, and it looks pretty neat. But until I've got a site selected, I didn't want to go through that much trouble, so I just made a simple extrusion and to simulate the Earth there. So it'll be walkout on the south side, and then it'll be earth sheltering on the north side, so you could step directly from the earth up onto the roof. And you could easily flip this around, but then you wouldn't get, if you flipped it around, then you wouldn't get the passive solar from the windows. And of course, we've got the same shading principles to shade the windows from the sun in the summer, but allow the sun to enter in the winter, especially at the winter solstice is what we aim for. It might be best maybe to move these up just a little bit depending on how much warming you want. You could move the solar panels and roof and everything up or down depending on how much heating you actually wanted from the sun. That's something that probably needs to be looked at a little bit, but this should work to get you what you need here. And these are, I changed this support design to be an immobile support, like the previous one would rotate, but you had these big long stanchions that came down to the ground, and you lose or gain about 12% efficiency, it seemed to me. So 12%, that's quite a bit of efficiency to lose with a stationary support versus a rotation support that you can rotate the panels into position. But also that means every month or every 2 months, I guess, you'd have to go out and rotate them. And those panels are pretty heavy. 3 of them together were like 160 or 120 pounds. It's quite a bit. So. And plus this will probably be sturdier, cheaper, less maintenance, and also it provides kind of a little porch area. The other one provides a porch area as well, but it has those stanchions out there, so you can't walk from one end of the house to the other. So I think whenever I go to build that I'll probably just do this stationary support as opposed to the one that's adjustable. For that reason, and I'll probably go with the fiberglass insulation because it's thinner and also because it's less expensive than the straw, and it's easy, you can find it, it's readily available with straw, and depending on your region, the time of year, etc., you may or may not be able to find the amount of straw that you need. So of course, it's still a good option, and there's other options out there as well. I was looking at maybe just an insulated metal panel and getting rid of this whole cavity altogether and just putting the insulation directly on the CMU wall. And that is something I'm going to have to look into a little bit more. That might provide even further cost savings if you just eliminate that wall altogether and put the insulation directly on the CMU. So that is one good option there as well that needs to be, I'll look into that a little bit more maybe. And then just standard details here. We added some shelving up high on the high portion of the house. Let's see if we can find a different view of that. Oh, it's on this view as well. Because it would be nice to have like a loft up here, but you're not going to end up with much room really up there for a loft. Especially after you get up above these windows, so there's only going to be like and then if you add floor joists in there or to support whatever, you're only going to end up with like a foot or two up there. So I figured it'd be better just to put some shelves up there. And then your standard window detail here. This is the same pretty much as the previous design if you watched any of my previous videos. This is the house design 9, by the way, and the other house was house design 8. I don't know if that really makes much difference to you, but And then I just wanted to show the stairs here. Like I said, these stairs are going to have to be modified by the carpenter. That's probably unacceptable to have a 2 foot landing, so it'll probably have to come down and then back down and then change directions a third time. And then we got all the schedules so you can have an easy takeoff and easy estimate. And then this is, the isometric view is just to give you a general overall idea of what it'll look like. Of course, part of it'll be underground, so you won't see a lot of that. And then easy access to the roof. That's an advantage of earth sheltered house. And then your site layout, we were able to reduce the size of the cistern and the septic tank because it's not as big as the House Design 8. Electrical, one thing I did add additional foundation drainage because if it's underground, if these 3 walls are underground, you want to have some additional drainage because the last thing you want is moisture issues on an underground house. And I believe I also included a note that says, like on to make the walls waterproof and not damp proof, because the last thing you want is moisture issues, like I said. It's not much to see on the electrical. We'll kind of just skim through that, but I laid out all the fixtures and receptacles, and one line diagram is it's similar but different. We ended up going down to like a 4.6 kW, 4.68 K. Sorry about that. 4.76 kW solar array because we could only fit 12 pounds. We might be able to fit 15 up there, but it doesn't. According to what the estimate I came up with, you wouldn't need that many for this size of house. And then a hybrid inverter, and then a power panel. And then all the schedules. You got your panel schedule, and then all your fixture schedules and everything for electrical. And then your general sheet we already looked at, and your standard mechanical sheet. Not much is really different with this design except I cut back on the ductwork some and have the fans through the wall, and then have undercut doors for all the doors to allow the air to circulate. Probably won't have as much cooling requirements for the underground house. I'm fairly confident you can probably just cool this house by using the ventilation fans only in your earth air heat exchanger. And we reduced the earth air heat exchanger from 4 tubes to 2 tubes due to the reduction in the size of the house. You can see here there's only 2 earth air heat exchanger tubes that go through the ground. We kept the radon vent similar to the previous design. And just, some minor updates to everything. I believe we reduced the water heater to a 50 gallon. That may have been what was in the previous design, though. Pretty much the same concept as before. Septic tank, the first flush diverter will have to change just a little bit due to the height of everything, but you may be able to get it above ground. It might not be a bad idea to put it underground though, since PVC is not UV resistant, so underground may be a better option if you have somewhere to drain it to. And just a couple of sections here to give you an idea of what you got going on everywhere. It's pretty busy in there. And some standard details. Of course, all your schedules for estimating and takeoffs. And then some isometric views so that you can size all your plumbing appropriately. And then we got structural last, and this is pretty much about like last time. We got our standard International Residential Code notes and requirements, and then we've got to take off of all the framing and concrete block. It'll be, of course, CMU walls for the structure, and then on the portion that's above ground for the walls, there'll be the chase wall with fiberglass insulation and 2x4 framing. Of course, any wood that's in contact with the concrete, that's in contact with the ground, should be pressure treated. The roof framing are those 16-inch I-beams. Those, I like those because they give you the 16 inches for your insulation, so that's kind of nice. And then here's some sections of all your CMU, some sections of all your framing, and then these are your of course, this view's just like kind of left over from the last project, but solar panel supports, you can't really see any supports from this angle, but you can from this angle here. And there's a bill of material. Oh, did I forget to update that bill of materials for the solar panel supports? I did, didn't I? Doggone it, I'm gonna have to go back and update that. That is no longer correct. Maybe I should just delete that off of there. I think I'm just gonna delete that off of there. Ay. Maybe not. Yeah, I'll just delete that off of there. And of course some isometrics of the framing, your floor framing, and your wall framing, and then your roof framing. And that's it, folks. That's all. Let's see, I'll go through all the, oh, you know what, I have to hook up my external hard drive to go through all that. I'll load all this stuff onto Google Drive, and I'll post a link in the comments if you want to download this design, and feel free to use it, abuse it, and well, don't abuse it. You want to make sure that you submit it to your code officials and everything. But you know, appreciate it you watching, and I'll flip through all the design documents real quick and then go ahead and post these videos.